Now let us see the apparent shift due to a glass slab. So let us take a glass slab of thickness T. This thickness is T, this refractive index mu. So if we have a point object here, and let us take a paraxial ray here, then this ray will bend and it seems to be coming from this point. So if we are an observer here, we will find the image of O to be I, that is, if this distance, let us assume this distance to be x, then this distance becomes mu x, as we have seen earlier. Now again here the ray goes on and then further it refracts and it seems the ray is coming from this point. So if we are an observer here and this is near normal incidence, then we will see the final image of O from this place at I. So now you see, so from this place, this distance is mu x, this is mu x plus t. So this is mu x plus t. So if this is mu x plus t, then if we are observing from here, the final image I will be observed at a distance mu x plus t by mu, that is x plus t by mu. So this is the final image here. So now you see here the shift, the net shift in the image distance caused by this slab. So shift here, shift delta, let us call it, becomes, what is this distance? Minus this distance. So this distance is x plus t minus x plus t minus x plus t by mu. So this becomes, delta becomes x cancel, t minus t by mu. So we have delta, that is t 1 minus 1 by mu. That is the expression of the net shift. Let us write it here. Net shift here, delta is equal to t 1 minus 1 by mu caused by this slab. The shift is in this direction. So we have seen here that a glass slab causes a net shift in the image, that total distance will be given by t 1 minus 1 by mu. Now if we have a number of slabs, then the total shift will be added, simply algebraically added like this. Now suppose there are a number of slabs. We have one slab, two slabs, three slabs. This has a thickness T1, this has a thickness T2 and this has a thickness T3. Here mu1, here mu2 and mu3. So if this is an object, so by the final refraction, if we see here, we will find the image to be somewhere, so that this is the given by, this is the net shift given by all these glass slabs. So the shifts will be simply added, that will be, delta will be equal to shift due to 1 plus delta 2 plus delta 3. So that will give T1 1 minus 1 by mu 1 plus T2 1 minus 1 by mu 2 plus T3 1 minus 1 by mu 3. So that we can write as sigma T I 1 minus 1 by mu I is equal to 1 to n. So this is the expression of the total shift due to a number of glass slabs. This is very important in problem solving, where there are different layers of liquids and it will be asked that at the bottom there is something, final image formation will be asked. Now let us take the first case. The human eye is seeing the fish. So this is the pot with the plane mirror. This is the water surface and here we have a fish. Now, here the fish is seen by eye directly. So, if it is seen directly, then a ray goes like this and further bends, and here this is eye. You see, this eye is here only, but since this is a paraxial ray and exaggerated diagram, showing it here. So, this is the fish and this is f dash, the final image formed here. So, this distance is h by 2. So, here to here distance becomes h by 2 mu and this distance is h. So, distance between this, let us denote by x. Distance between the fish, the image of fish directly, and this I becomes x is equal to this h plus h by 2 mu. So, here the fish is directly seen by us at this point f dash. Now, here I, next case, I sees the fish in mirror. So, if this is the case, this is the plane mirror and this is the fish f. So, let us take up a ray from the fish that gets reflected. This ray is reflected. So, you see this is f dash or f1, let us call it f1. So, this is the image of fish in the plane mirror. If we are here, we will observe the image to be, if this is h by 2, this is h by 2. So, at a distance of h by 2 from here. Now, this ray further bends and goes like this. So, this is the final image. This is the final image f double dash f2. Let us write it f2. So, this is the final image formed and its distance will be here. This is h by 2 and this is h. So, 3h by 2. So, this becomes 3h by 2 mu and here is our I. This is normal incidence. This is exaggerated diagram. This is h. So, here x becomes this h plus this is h plus 3h by 2 mu. So, this is how with the help of ray diagram this eye sees the image of fish in water, here directly and here the image of fish in water. So, two images will be seen by the eye, one directly, one by the reflection due to plane mirror. So, two images are there, one is formed here f dash, one is at f2, note it. Now, let us see how the fish will see the eye, that is fish sees the eye directly first. First, this is the case, fish sees the eye directly. So, this is my pot with this plane mirror and this distance is h. This is our eye, location of eye. Now, any ray from here bends towards the normal and seems to be coming from this location. So, this is I dash, the image of eye as observed by the fish. Here we have the fish and this observes. So, if this distance is h, then it will be appearing at mu h and this distance itself is h by 2. So, we see that the distance between the fish and the image of eye is this h by 2 plus mu h. This is where the fish will see the eye if it sees upwards directly. Now, if this fish sees the eye in the plane mirror, so it has to look downward and image will be formed somewhere here. So, now fish, second case, fish sees the eye in the mirror, this case. So, this is the water, and suppose I am drawing here, this is our eye at a distance h. So, when a ray goes like this, it bends like this, so that it seems to be coming from this point. This distance is mu h, mu h. This distance is h, so it becomes mu h. Now, this ray here reflects, and if I extend it, this is a plane mirror, extend it, then it seems to be coming from this point. This is E, this is E1, and this is E2. E2 is the image of E1 in the plane mirror. So, this is mu h, this is h, so this is mu h plus h distance. So, mirror means mirror forms the image at the same distance on the other side. So, this is the distance of image. So, now here we have the fish, and this distance is h by 2, h by 2. So, between this is the final image of the eye in the plane mirror. So, here x will be equal to this mu h plus h, mu h plus h, and h by 2, that is 3h by 2. So, thus fish sees the eye directly at E dash, and fish sees the eye in the plane mirror at E2. Distances are given by this. So, this is the problem. We got these values, and we have seen how the image formation with the help of ray diagram. These diagrams are very important in understanding how shifts are taking place, how the ray is refracted, how it is reflected. Now, let us see apparent depth for an oblique incidence. Till now we have seen the apparent depth for a normal incidence. That is, if the observer is here and the object is here, this is mu, and this medium has a refractive index 1 and mu, then the image will be formed at some location here. This is I, and this is the shift caused. So, if this is h, this is h, then the image will be formed as h by mu. This was our previous case. Now, we are interested in oblique incidence, that if we have an object at a depth h, and if we see at an angle, so any ray going like this, if we see at some angle, here angle is theta, then where will be the final image? So, the final image will be here, and this will be h dash. So, this time the h dash won't be h by mu, but it will be something else that we have to find out, and this is the angle of vision. So, this time we are really seeing the things obliquely. This is not an exaggerated diagram, this we are seeing really at this angle. So, this is not normal incidence. So, now what happens? Already we have discussed that the deviation increases with the increasing angle. So, you see, when this angle of incidence is I, it becomes I plus di. So, this deviation increases. So, this theta becomes theta plus d theta, and so they converge at some earlier point here. So, from this line they converge this side, they get this side, and so this we have to now determine what is h dash. So, now this is the object at a depth of h, and this is seen from here at an angle of vision theta. So, when these rays goes to the eye, it bends and an image is formed here. This h dash we wish to calculate. Here the angle of incidence is I, so this becomes I, these are parallel lines, and here the angle of incidence decreases by I plus di. So, the total angle becomes I plus di, that means this is di. This is theta, So when I produce these rays, this angle will be theta and this angle will be again theta plus d theta. So total angle theta plus d theta. So we will write d theta here only. Let us give name A, B, C and D. So now let us see triangle in triangle AOC and triangle AOD. AOD. So these two triangles we are considering. So AC, this is I. So AC becomes, AC by H is tan I. So AC becomes H tan I and AD becomes H tan I plus DI. We want CD suppose. So CD, this CD is the difference of AD and AC, these two difference. So that is AD minus AC. So here we will use some approximations. H tan I plus DI minus H tan I. So this CD will be H sin I plus DI by cos I plus DI minus sin I by cos I, where we have taken H as common. This is a very important point. Now we are going to simplify this. H, this is cos I plus DI into cos I by sin I plus DI cos I minus sin I into cos I plus DI. This is sin A cos B cos A sin B. So we will write this as sin I plus DI minus I by cos I plus DI into cos I. So we got some simplified result. This I gets cancelled. CD is H times sin DI by, now here cos I plus DI is so small that I can neglect this DI. So I will get cos I into cos I is cos square I. So we have CD is equal to H. Now DI is small angle, so sine of small angle is that small angle itself. CD is equal to H DI by cos square I. So this is very important result. Let it be written as equation number 1. Please note this. Now similarly in triangle BCI and triangle BDI CD can be written as BD minus BC. CD will be written as H dash tan theta plus d theta minus H dash tan theta. So similar to our previous case where we got only H tan I plus DI and H tan I. So similarly this we got for CD. Thus CD will be equal to H dash d theta by cos square theta. As we got earlier expression, this similarly we will get. So this is equation number 2, this is 1. So from 1 and 2, equation 1 and 2, we get CD is compared. So H dash d theta by cos square theta is H di by cos square I. So we got d theta by di is H by H dash cos square theta by cos square I. This is the most important result. Equation number 3. Please note down these steps. Now, applying Snell's law here, applying Snell's law, sin mu sin I is equal to sin R. Now we wish to know how theta changes with a change in I, keeping that this theta and I, R is written as theta here, how theta and I varies when they are related by mu sin I is equal to sin theta. So we will differentiate mu cos I di by d theta is equal to cos theta. So we have di by d theta as cos theta by mu cos I. This is equation number 4. And from equation 3rd, so from earlier relation we had already equation number 3, that is d theta by di we got as H by H dash cos square theta upon cos square I. So this was earlier equation 3rd. So now we couple these equations, we get cos theta by mu cos I, this is di by d theta, will be H dash by H cos square I by cos square theta. Now we wish to calculate H dash, which implies H dash will be equal to H cos cube theta, H cos cube theta by mu cos square I. Now theta is known, the angle of vision is known, we have to calculate I. So we will replace these by using this. So that will be further written as H cos cube theta upon mu cos, this is cos cube I. So now cos cube I will be simply, here I is unknown, theta is known, so we can replace cos cube I by cos theta. So we can write cos square theta to the power 3 by 2. Cos square theta to the power 3 by 2. Now cos square theta is 1 minus sin square theta. So we can write, let us write here only. So now again cos square theta I am replacing as 1 minus sin square I. So 1 minus sin square I is simply again 1 minus sin square I. I means theta here. So this is the expression for H dash. So you see, in my previous result, when it is normal incidence, H dash was equal to H by mu simply. But now H dash is related by H by mu, and so theta will be there. So you see, when I put theta is equal to 90 degree, we get my previous expression. So this is how the image formation for oblique incidence will take place.